All right, welcome back to Conics sections. We are on the third section of Conics sections, and remember we started off with parabolas. This is a slanted, it's parallel with this axis right here, a slanted cross section of a cone, that's called the parabola, and then we did the hyperbola. Hyperbola is where we have two parabolas, kind of like a cross section that cuts through the top cone and the bottom cone. And then today what we're going to be working on is the this horizontal parallel with this base right here. We've got the circle, and then we've got a slanted cross section, which is called an ellipse. So circle and ellipse. So know your conic sections, especially for the PHEC quiz that's going to be coming up. So let's talk about what to look for when it comes to these conics. So here, you guys remember what this is? Good. This is a parabola. And let's say this one right here, what do we call this? That's our hyperbola. And then when it's at a slant there, that's an ellipse. And then we have a circle when it's going to be parallel with the base there, or with this section right here, that plane. So we've got a parabola, hyperbola, ellipse, and circle. Remember, this is the PHEC order that I want you guys to go in when it comes to telling the difference as you guys see these equations on your quiz. Okay, so a parabola, how can we tell a parabola apart from all these other equations? Well, a parabola is going to have a one squared variable, and then that's it. I mean, in a hyperbola, what do we know about a hyperbola? Well, hyperbola is going to have two squared variables, but so is an ellipse and a circle. So it's like, how do we tell the difference between a hyperbola versus an ellipse and a circle? Well, when we look at those two squared variables, they're going to have opposite signs. Okay, when they're on the same side of the equation, they're going to have opposite signs. Okay, so over here, the ellipse and the circle, they're going to have the same sign. So both of them, right now, they're identical. So how do we tell the difference between the ellipse and the circle? Well, when we look at their coefficients and also the denominators. Okay, so different coefficients or different denominators, all right? And then a circle is going to have same everything all the way down. Okay, and this is what you're going to be quizzed on when you guys are taking this PHEC quiz coming up to a desk near you. So, ellipses and circles. Let's go over just something real quick. This is completing the square. Completing the square is a process that we use to solve a quadratic. We're going to be analyzing this a little bit because sometimes we'll have to take these equations, these conic sections, and put them into standard form, especially if you're in Math 3 Enhanced. Okay, so putting these in standard form means that they have parentheses. So let's just go through this real quick. Okay, so this is a quadratic. We can tell because it has one squared variable. Okay, it's set equal to 0. So what we're first going to do is we're going to see if anything's factorable. Nothing is factorable. There's not a common factor in all three terms. So what we're going to do is now solve by using CTS, which is completing the square. Okay, so first what we want to do is isolate the squared x term and then the x term. So that means these two guys right here. So that means get rid of this 12. So I'm going to subtract 12 from both sides. So now I got that. Okay, then next we're going to use the formula where we take the b term, which remember this is the b term, remember a, b, and c. We're going to take the b term, divide it by 2, and then square it. So if I was to take that 6, divide it by 2, okay, 6 divided by 2, it's going to be 3. And then if I was to take the 3 and then square it, that gets me 9. Now see what I did to this equation. Like if we're just looking at an equation, before I put this red thing here, all this little stuff, okay, we just added 9 to this side. We can't do that in an equation and it still be equal on both sides unless I add 9 to the other side. So to keep this equation balanced, we have to add 9 to both sides. Okay, but the reason why we added 9 is because now we're going to write this as a perfect square trinomial. Think about if we were to use the x and factor this. What are factors of 9 that would give us 6? And what I mean by that is, like, if we were to take this and say, okay, 9's right here and 6 is right here, what are factors of 9 that would give me 6 if I were to add them up? So we see 3 and 3. So when we go to write this out, we have x plus 3, and then over here, this one's going to be exactly the same factor as x plus 3. Now there's another way that we could write this whenever there's two factors that look exactly the same. We could write it as x plus 3 squared. And that's really what we're going to do here. And that's the goal of completing the square. Okay? So instead of writing it like this, we're going to write it where we factor the left side and we get x plus 3 squared. Does everybody understand how I got this? All I did was just factor this. And notice the 12, the negative 12 and the positive 9, that just simplifies to negative 3. Okay, now if we were going to solve this, right, we would then, to undo a square, we take the square root and all that stuff. Okay? All right. So when we take the square root, subtract both sides by 3, and we solve this quadratic by completing the square. That's a process. But you guys see how we stopped right, or we're in the future here. We're going to stop right here where we have these parentheses, and I'm going to show you guys how to put these PHECing questions in standard form. Okay, so the big thing here. Oh yeah, since we have a negative, the big thing here is that we've got we have an imaginary whenever we have got underneath a radical. Okay, but to understand when to use completing the square, like right here, this example is pretty easy. Now obviously there are some more challenging ones, like for example this one. Okay, if I'm going to use completing the square, you see how we have a 2 in front? That's just going to throw a wrench in this whole system. Okay, but let me show you. All right, so if the completing the square can only work if the a term is 1, we have to divide everything by 2. Okay, so we're going to divide everything by 2. This by 2, that by 2, all of those by 2. So look, we just made this equation pretty ugly. All right, but we can still follow the procedure, just like before listed on the previous slide. We're going to isolate the x squared term and the x term. So add both sides by 1/2, move that over. Okay, and we're going to take this, divide it by 2. All right, if I divide by 2, it's the same as multiplying the denominator by 2. So that'll be 7/4. Okay, and then square it, so that's squaring the top, square the bottom. So 7 squared is 49, 4 squared is 16. Okay, so we just added 49/16 to this side, and we have to do the same thing over there. Now let's kind of clean this up a little bit. If I was to add those two things together, then I end up with this. All right, now if I'm going to factor this, which might be kind of confusing, but just remember, if I go back to our previous example, see this number that's right here, the +3, that's the same number right before we squared it and we moved it up here. Okay, so whatever's right here is basically going to be right here in our factors. Let's go back to this. So right before we got this 49/16, it used to be 7/4. So when we go to write our factors, it's going to look like that, 7/4. Okay. Now the same process. Look, this is as far as I kind of need you guys to go today, but let's just go for it because we're overachievers. If in order to solve for x, we need to undo the square. So we take the square root of both sides. Can't take the square root of 57, but I can take the square root of 16. Don't forget the plus or minus. All right. So we know that that's 4. And then we subtract the 7/4 over. And then since both the denominators are 4, we can kind of pile that together. And then we got our answer. So that's a real quick overview of completing the square. All right, so now let's go back. Okay, so our first PowerPoint our lesson that we learned is all about parabolas. So remember, when it comes to a parabola, it has one squared variable. We also know that it can come where the x is the squared. Okay, and that's going to be a happy face, sad face type of parabola. We also know that it could come like this, where the y is squared. That's going to be a c backwards c parabola. Okay, now each of these parabolas have this thing that's called a focus and a directrix. The directrix is a line that's going to be on the opposite side of the focus with regards to the parabola. So notice that the focus is right here, the directrix is right here. So the parabola always opens up towards the focus. Okay, so this is a function, this is not a function. And when it comes to finding the focus and the directrix, the distance from the vertex to the focus is our c value, and we use this very important formula called a, absolute value of a equals 1/4c. Okay, and the a is representing this value that's right here. All right, then last time we looked at hyperbolas, and we know that they're two squared variables and they have opposite signs. Here's an example of an equation. Remember, this h and k moves the center, and then this a and the b dictates whether or not it's going to be horizontal. I'm sorry, the positive of the two. So if this is positive, then that means it's going to be a horizontal hyperbola, and if this is positive, then it's going to be a vertical one. Okay, so this one's a horizontal, this one's a vertical. All right, now today we're going to be looking at an ellipse and also a circle, but remember, an ellipse is going to have two squared variables, same signs, but different coefficients and different denominators. Okay, so here we have two squared variables, same sign, but it's going to have different denominators or different coefficients. This is the standard form for an ellipse, and sometimes it doesn't always come in standard form, and I'll show you that in a moment. Okay, so a is, in this case, is going to be representative of the bigger number. So if a is the bigger number, if a is bigger and it's under the x, then it's going to be growing in the x direction more than it's growing in the y direction. Okay, so if A is the bigger number of the two. That's what this is indicating. A is bigger than B. If A is underneath the Y, then it's going to be growing further in the Y direction than it is in the X direction. So that's the two different ways that an ellipse can be graphed. All right, and then lastly we have a circle. A circle is two squared variables, same signs, same coefficients, same denominators. Okay, and this is an example or an example of a type of equation for a circle. Notice we have a h and the k. We have a h and the k. H and the k. That's just the center of each of these graphs. Okay, now the r represents the radius. So if I have this example, all right, it's not moving anywhere with regards to its center. It's going to be at the origin, but my radius, this is radius squared, my radius will be 4. So notice that it goes out 4, goes up 4, and then we just draw the circle. Okay, so something really important that I wanted to hit and touch on here, and that is, just going to move that up a little bit. That is that right here, this is a very important formula. This one right here, this is how we find the focus and the directrix for a parabola. Okay, now for a hyperbola, we learned a special formula for finding the focus here. There's no directrix for this, but these two, so whenever you have two focus, it's a foci or focuses, I guess. Depends on how you pronounce it. But anyways, the formula for finding the focus for this one was a squared plus b squared equals c squared. So this is the a, this is the b, and the c is going to be the distance from the center all the way to the focus. That's the c. Okay, so now an ellipse also has a focus, and to find the focus for an ellipse, it's going to be a squared. Remember, a is the bigger one, right? A minus b squared will give you your c squared. Okay, so notice the difference here. The focus for the hyperbola is going to be further, right? It's further, okay? And then this one, since I'm subtracting, that means it's not going to be as far. That means it's not going to go past that point right there. Notice that the focus, the c value, is only going to go to right there. Okay, that's going to be the c value. So the focus is only going to be right here. Notice that it's only on the larger of the two axes. So the axis, this is an axis, this is an axis, this is the major axis, this is the minor axis. Okay, so this is very important. If you guys are still taking notes on that piece of paper, I would say jot those two down for an ellipse and a hyperbola. And circle really doesn't have a focus. If anything, I guess the focus is right in the center. Okay, so let's see if we can tell the PHECing difference coming up here. All right, so what the PHEC is this equation here? So remember to go in the PHECing order. You start with the parabola. Parabola is, it has one squared variable. So I see I have one squared variable, so that means that this is a parabola. Boom. So notice that it says classify each conic. That's what you're going to have to do for the test, or the quiz, excuse me. But do you guys see how the answer, it's written like this? So how in the world did they get this? How did they get all of this to look like this? Well, they used completing the square. So I wanted to show you guys real quick how they did that. So first, notice that the y is by itself. So I'm going to do that. I'm going to put the y on one side, and I'm going to move over the 21. I'm going to move over all this stuff. So notice now I'm going to have x squared. So I added x squared to both sides. Here, I can do that. So now x squared's over here, and now I'm going to subtract the 10x, move it over to this side, so minus 10x. And then that 21, since it's a minus 21, I'm going to add 21 to both sides. So I add 21. Okay? So here we have our old school standard form. Basically, this is vertex form. So to put this in vertex form, we're going to use that process of completing the square. So I'm going to leave, let's see, I'm going to put the y right here. I'm going to put the x squared minus 10x. And I'm going to kind of like put it in brackets because I'm going to just mess around with this part. And on the outside, I'm going to put the plus 21. Okay, so I want to just complete the square for just this portion right here. So let's go ahead and do that. This is our b term. If you remember, the formula is b divided by 2 squared. So negative 10. So if I had negative 10 and I divided that by 2, that would be negative 5. Negative 5 squared would be positive 25. Okay. Now what did I just add to this side of the equation? I just added a 25. So I have to keep my equation balanced, and I have to add 25 to this side. Okay, so let's kind of clean up what we have here. We have 25 over here. We have the y. And we have all of this. Now remember, if we were to use the x and we were to factor that, what are factors of 25? That would give us negative 10. that'd be -5 and -5. So notice, remember, whatever it is right before you squared it, that's going to be your binomial. So we're going to just factor this portion right here. So this is going to be x minus 5 squared, and then on the outside we have a plus 21. Okay, almost done. Notice that the y is by itself over here, so we just need to get the y by itself. How do I get the y by itself? We're going to subtract 25 over here and subtract 25 over here. So then you can see in our final answer, you have x minus 5 squared, -25 and a positive 21, that would be -4. So that's how they get that value. Okay? Now, in a couple other ones you're going to see in a moment, you'll see that they just you just do completing the square twice, and I'll do that example possibly. Okay. All right. So this one right here, what the feck is it? What do you guys think? Good. One squared variable. If it has one squared variable, that means that this is going to be a parabola. Okay. Let's try this one. One squared variable, parabola. All right. This guy right here. We have two squared variables, so it's not a parabola. Two squared variables, and they're not opposite signs. So notice we're going to be looking at it always whenever it's on the same side of the equation. So here's the equal sign. It's on the same side, and so that means that they're both positive. Okay, now look, these are still same signs if they were both negative. If this was negative and this is negative, they're still the same. Okay, so make sure you understand that. Also, make sure if it's x squared equals y squared, these aren't on the same side of the equal sign, so you have to move them over there. X squared, subtract the y squared over to the other side. Okay? So be on the lookout for that when you're taking that quiz. Okay, so we have, so it's not a parabola, we already said. It's not a hyperbola because they're not opposite signs. And then since the coefficients are the same, or the denominators, that means that this is going to end up being a circle. Okay, notice that this is what it looks like, and then here, this is your standard form for a circle. So again, they would just use completing the square twice. So I'm going to go ahead and show you guys how to do that, and then that'll be the last kind of difficult thing that I think we're going to do in the first part of this lesson. Okay, so first what I'm going to do is I'm going to write all the x terms together. Okay, so I have x squared plus 6x, and I'm going to kind of keep that group together. Okay, then I have y squared and -2y. I'm going to kind of keep that together. And then on the outside here, I have the equal sign. I'm going to take this constant term, the 9, and I'm going to go ahead and subtract it over to the other side. So here's -9. Okay, now I'm going to complete the square twice. So I'm going to take this, and here, let me scroll up a little bit. Okay, so this 6, if I were to take 6 and divide it by 2, that'd be 3. 3 squared would be 9. So I just added 9 right here. Okay, now if I was to quickly change this into what it should look like as a squared binomial, remember the 3 is the key, right? The 3 right before we squared it. So then that's going to be x plus 3. Okay, now I'm going to go ahead and look at this one. This is a -2, so -2 divided by 2, that'd be -1. -1 squared would be +1. Okay, now I'm going to clean it up a little bit, write it as a binomial squared. Remember, that's my key number right there, right before I squared it, which is -1. So then that'll be a y minus 1. Okay, and since this was a positive, we keep that as positive right in between. Okay, so notice that's where they got that x plus 3, and then right here, this y minus 1, that's where they got that. Okay, so how did they get that 1 here? Well, there's a couple things that we forgot to do. If you notice, we added 9 right here, and we also added 1. So remember, to keep our equation balanced, we have to add 9 over here. Let me make this red. We have to add 9 to this side and also add 1. So notice that these 9s right here, they're going to cancel, and you're just left with 1. So that's how you would write this in standard, or I'm sorry, in standard form of a circle. Okay, by completing the square twice. All right, what the feck is this one? Well, we've got two squared variables, so that means it's not a parabola. The signs are the same, so that means it's not a hyperbola, but it has different denominators, so it's not a circle, it has to be an ellipse. Okay, let's look at this one. Two squared variables, so it's not a parabola. If it's not a parabola, then it's got to be either maybe a hyperbola if it has, yep, look, opposite signs, so that's going to be a hyperbola. Okay? All right. I think we're pretty good. I would say you guys could look at these and pause the video, and if you want to practice, see if this is what the effect this one is. Just see if you can tell the difference. See if you get that answer. Okay, try this one. Pause it. See if you can get the answer. Okay, what the heck is this one? Pause it and then check your answer. What the heck is this one? Pause it. You can get your answer. All right. So we're going to talk real quick about how to graph a circle. It's really easy. It's not necessarily in an enhanced version, okay? So notice that it says identify the center and the radius. So the center here, since there's no numbers on the inside with the x, that would be 0, 0. And then the radius, this is the square of the radius. So we would say the center is 0, 0, and the radius is 7. Pretty basic. Let's try this one. What's the center and the radius? All right, so there's no numbers in here with the x and the y, so it's going to be 0, 0. And then what's the square root of 324? All right, good, 18. All right, so watch this. It says identify the center and the radius of each. Okay, so something to remember, okay? Our center is going to be an ordered pair where this is your h and this is your k. Now remember in the formatting it says x minus h. So that means we have to take the opposite of whatever number is right here. So the x value is going to be -1, and then it's y minus k, so we have to take the opposite of this as well. So that means that that's going to be +2. So the center is going to be -1, +2, and then the square root of 9 will be our radius is 3. That's how you figure that one out. Okay? -1, 2, radius 3. Why don't you guys try this one? What is the center and the radius for question number 14? All right, so center is -2, -3, and the radius is 2. Nice job. Okay, so what if I gave you the center and the radius and I wanted you to come up with the equation? So what would that look like? Well, if we were to kind of write down just the format, we know that it's x minus h squared plus y minus k squared equals the radius squared. So if I know the radius is 5, that means that we could say, oh, okay, that's easy. I know that I could throw in a 25. And now over here, I know that the x is always going to stay there, but the h and the k, right, those are going to be the things that are going to be moving and changing, all right? So if the center is -1, so see, -1, so that means it's going to be a +1 here. And then -2, that means it's going to be a +2 here. And that's how we come up with the equation when we're given just the center and the radius. It's really easy. Circles are probably the easiest one. All right, so let's try another one. Let's see if you guys can come up with the equation. All right, so I'm giving you the center and the radius. See, that one's, I know it's got a radical. It's okay, you guys can handle this. What is the equation? All right, so check your answer. See if you guys got that. Okay, remember you just square this and square that. So 2 squared would be 4, and then the square root of 2 squared would be 2. 4 times 2 would be 8. Okay, how'd you do? You all right? Awesome. Okay, so now this is the Math 3 Enhanced. This is a little bit deeper looking at this. So stop the video, or you can continue on if you wanted to learn a little bit more. All right, the next part of this is we're going to be looking at an ellipse and the key parts of an ellipse, which one being the focus. Okay, so if you are taking notes, okay, to find the focus of an ellipse, where the plural is the foci. So watch this. Imagine if like you guys can't see my hands, but imagine if I was holding up my hands like 2 C's. Okay, so if I had my hands kind of making a C form, like I don't know, maybe I could go like this. There's my hand, okay, and there's my thumb. Okay, so there I am holding and making a C, and then if I was to do my other hand making a C, when my fingertips would, let's say if this one was going this way and this one's going this way, when they meet, that's when we would create an ellipse. Okay, so we have a couple different parts. That if it's an ellipse, that means that this axis would be a lot larger than the axis that's going this way. So we know that with a circle, if the radius is 5 right here, that means that the radius is 5 right here, but not so with an ellipse. An ellipse has different radii in either direction. Okay, so imagine if I was to hold my hands a different way, where it was like this and like this. Okay, so now we have a vertical directional ellipse where this is the longer axis and then this is the shorter. So the longer axis we call the major. Okay, so then right now the major is the one that's going up. Okay, and the blue one right here, this vertical one, this would be the minor. Okay, so then the blue one right here, this is the minor axis. Okay, so we have a major axis that goes all the way across and then a minor axis. Okay, and really how this works when it comes to an ellipse is you find the center, which is going to be the same exact way on how you found the circle. Okay, so let's say that it's x minus 2 and then squared, and then over here it's, oops, that should be a y plus 3. We know that we're going to move the equation to the right 2, down 3. Okay, that's how we find the center. Okay, now the difference is that in standard form for an ellipse, it's going to be equal to 1, and then it's going to have different denominators. So if the x, let's say that the x underneath the x is 81, that is going to be your a squared. Okay, now the reason why I'm going to classify that as my a is because it's going to be the bigger of the two denominators. Okay, so in the x direction, I go 9 units this way, and I go 9 units this way, kind of like a circle, okay, like the radius is going in both directions. But in the y direction, I'm going to be going only 5. So 5 units this way and 5 units this way, okay? And then at these are called our vertices here. Let me make them green. These vertices right here is what we're going to be plotting, and then that's how you graph your ellipse. Okay? So the ellipse looks like this. So that's why if the bigger number is underneath the x, it's going to be horizontal, and if the bigger number is underneath the y, then it's going to be a vertical one. Okay, so now finding out what where the focus is, the focus will always be on the major axis. So the focus is going to be a dot somewhere like right here. Okay, and how we find that distance, which is our c value, is what I told you before, is that you go a squared minus b squared, and that's going to be the c distance going to your focus. And that's pretty much it. Okay, so now I'm going to go through this slide. It's got a lot of information, but I just kind of summed it up right before, so hopefully the second time that I go over this, it makes a little bit more sense. So here's an ellipse. We have a major axis, like I told you, it's going to be the larger of the two axes. We have a minor axis, which is going this direction. Okay, we have a focus that's going to be this. There's going to be one on this side, always on the major axis. Okay, and then this value right here, this is going to be the distance a. This is going to be the distance negative a, going in the opposite direction. And then b, remember the b is underneath the equation. Okay, b going this way, b going this way. All right. So major axis is basically the segment that contains the focus, okay, and has the endpoints of the ellipse, okay, and then we have the endpoints of the major axis are called the vertices, okay. I already kind of talked about that, and then yeah, the center. Okay, so minor axis is going to be perpendicular, like I mentioned, okay. All right, so it has these things called co-vertices. So these are called the vertices. These are called co-vertices. All right, so. And in an equation, remember A is always going to be the larger of the two. So this distance from the center here is going to be the A if you took the square root of it, right? And then this distance right here is going to be the B if you took the square root of it. Okay? So same thing if you have a vertical one. All right? So remember A is always bigger than B. Okay? So it's, in this case, the A is the bigger one, so it's underneath the Y. So now notice the major axis is going vertically rather than horizontally. Okay? All right, let's try some problems here. So it says the vertices are at 10 and negative 10, and the co-vertices are at 0, 9, and 0, negative 9. So it says use the information provided to write the standard form for an equation of an ellipse. Okay, so what I'm going to do is write down the standard form of an ellipse. Okay, and that was on the previous slide where it has all the information on it. So x minus h squared plus y minus k squared, always equal to 1, and then divided by, and then this could either be a or b, but it's going to be a value squared. Okay, let's say it's a squared and this is b squared. Okay, so what I'm going to do here is I'm going to go ahead and draw a coordinate plane and then see what I see here. Okay, so the vertices, now remember vertices are going to be on the major axis. Okay, co-vertices, so this is major, this is minor. You can't really see that. Let me change that, minor. Okay. So vertices are at 10, so that's an x value. So at 10, that's a vertice, and then at negative 10, that's another one. So already I know that it's going to be a horizontal. So if the distance from here to here is the same on either side, that means that this is the center. So that means when I'm writing my equation, it's going to be an x squared plus y squared equals 1. Okay, now all I got to do is just come up with the denominators. So here, since this distance right here, this is my a value, which is 10, that means that a squared would be 100. Everybody understand how I got that? Okay, now the covertices are at 9. So from here it goes up 9 and goes down 9. Okay, so just a confirmation that we know that the center has got to be in the middle between those two values. So that means that this would be 81. And bam, that's how we come up with our equation. That kind of makes sense? All right, so let's see if you can figure this one out. Go ahead and give it a shot. Okay, so for this one, I got this as an answer. Now notice that the covertices are on the x-axis, so that means that our covertices are going to be, so this is it's going to be a vertical ellipse. So what I mean by that is covertices are on the x-axis, so that means it's going to be smaller growing in the direction here, and it's going to be larger in the y direction. See how the y is right here? Okay. All right. So here's an example where it gives you the foci and it gives you the vertices, and you have to come up with the equation. All right, so let's go ahead and try to mess around with this. Let's see what we got. So if the vertices, I'm going to draw a coordinate plane. The vertices are on 12, negative 12. Okay, so 12 and negative 12. So that means that it's going to be centered, x squared, and I know that it's on the x-axis. That's the major axis. So then I'm going to put 144 right here. Okay, and I know that that's always going to be plus. It's going to be y squared, and we don't know what the b is. We'll just put b squared right here, and then equals 1. Okay, now it gives us our focus. Now, how are we going to figure out what the b is if we know what the focus is? If the focus is some distance out here, 2 radical 11. Okay, that's where our focus is. So there was a formula that we learned earlier. Remember, it was a squared minus b squared equals our c squared, and our c is our distance to the focus. So we know the a squared is 144. We don't know what b squared is, so we're just going to write minus b squared. And then we know what our c is, well, sort of, okay? We know our c, this is c. Our c squared would be the value that we put right here. So if I have 2 radical 11, if I take that and I square it, I square the 2, that'd be 4. Square the radical 11, that would be 11. So 4 times 11, that'd be 44. Okay, now we want to solve for b. So I'm going to subtract 144 from both sides. Notice that on this side I'm going to end up with a negative, but that's okay. Minus 100. Because over on this side we see that the b is negative. Okay, so if the b is negative and this is a negative, we know that we can divide by a negative 1 and cancel that out. So we get our b squared is 100. So I'm going to go ahead and replace that with 100. Kind of make sense? All right, so a lot of these problems that you're going to see on the worksheets and stuff are going to have little variations of that, but if you just use your problem solving abilities, you should be able to figure it out. Okay? All right, so like I said, we already kind of went over that. That's how we figured that answer out. Okay, you guys can try this answer, or I'm sorry, try this problem and see if you can get an answer. All right, so hopefully you solved it the same way. I got an answer as x squared divided by 196 and y squared plus y squared over 25. All right, so it says find the foci of the ellipse with the equation, and it gives you the equation, and then it says to graph the ellipse. So we're going to go all the way, and this will be our last example. All right, so here we go. All right, so we know that when it comes to an equation of an ellipse, it's always equal to 1. So that's our first step, okay? We want to make this equal to 1. So how do I make this 225 equal to 1? Well, I divide by 225. So that means I got to divide this by 225, and I got to divide this by 225. Okay? So after I divide that by 225, we are just going to check it out and say, okay, if I was to simplify this, we have x squared. Now how many times is 25? go into 225. It's going to be 9 times. You can use your calculator. And then over here, 9 goes into 225. That's going to be 25. So y squared over 25 equals 1. All right, so now we have our standard form of our equation. Notice that our center, that's what we're going to do first. Our center is going to be 0, 0, 0, 0. Okay, and then step 2, we're going to go ahead and plot that, but we want to know, is it going to be a horizontal one or is it going to be a vertical one? Well, since the number underneath the y is bigger than the number underneath the x, that means that it's going to be a vertical one like this. Okay, that's good to know. And if we, that means that this is a, this will be a squared, this will be b squared. We can figure out what our c squared, that's number 3, we're going to find our focus, or foci, okay? So if we have a squared, which is 25, minus b squared, which is 9, that'll be 16. Take the square root of that, and that'll be 4. So the distance to the focus will be 9. Okay, so let's go ahead and graph this. I've got my coordinate plane. I'm going to draw up here. Coordinate plane. Boom. Okay, so our center is at 0, 0. I'm going to go ahead and put that. Now, since it's let's see, in the x direction, I'm only going 3. So 1, 2, 3. In the x direction, 1, 2, 3. This is our minor axis. So the total distance of our minor axis is 6. Okay, and then our major axis is vertical. So I have to go up 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we could go ahead and draw. This will be our vertices, remember, and then these are our co-vertices right here. So, and there's our ellipse. And then our focus is always on the major axis, and our focus is 4 units away. So from here, 1, 2, 3, 4, there's our focus right there. And then it's also down here. Okay, so let's label a couple things here. We have this blue line right here. The blue line is the major axis. Okay, then we can say the red line that's cutting across here, that's our minor axis. Okay, and then we have our focus, which is right here. Focus is going to be at the ordered pair. What is that? 0, 4. And we also have a focus down here at 0, -4. Okay? Alrighty. So, that's pretty much it when it comes to this. And I got the graph right there for you. Okay, so something kind of fun. Eccentricity is how uncircular a curve is. So E can be found by taking the C and dividing it by A. So I'm just going to show you guys something kind of relevant to our natural world. So here's our formula, obviously, where you can find C. So eccentricity is how uncircular. So remember, a circle is going to have an equal radius all the way around. So the greater the eccentricity, that means the more elliptical that it's going to be. All right, so this little equation right here is kind of fun. But basically, if you were to take this and type this into Desmos, if we were in class, I'd show you guys how to do this. Let me go to Desmos real quick. Let's see. All right, so Desmos, so I put in this equation, and right here, you guys can see this is the sun, and then the ellipse of the planet of Earth looks like this. So it almost looks like a circle, okay? And then the distance from the sun to the Earth is 1 AU, which is 93 million miles. So this is 93 million miles here. Notice that it's not quite 1 AU, but up here it is. Okay, so it's a little bit elliptical. And then the red one, that's Mars. And then check out Uranus right there. Okay, Uranus is right there, and then the black one, that is Pluto. So now I found on Desmos that you can type in all of the elliptical orbits of all of the planets. So here it is. Check this out. All of them look like this. Now I want you guys to notice, look, this is what this thing looks like. But let's take a look at all the equations. Like, this is pretty intimidating, but check this out. Do you guys see how these equations aren't so foreign to us now? We should be able to look at this and go, oh, I know what this is. Okay? Notice down here, look, this is still 2 squared variables. okay, but it has different denominators. So we're looking at an ellipse, two squared variables. These are all ellipses when it comes to these equations. So now you guys should hopefully be a little bit more familiar with that. All right. Okay, well, that was all I had for you. Here's some extra practice problems if you would like to try it. Don't do question number 39, that's kind of weird. Okay, but you can give it a shot, and then here's the answers to check as you guys are working on this. Good luck. Those are the answers highlighted in yellow. And until next time, see you later.